Section 5.2 discusses polynomial functions and adding and subtracting polynomials. So in this section, we're going to introduce something called a polynomial. But as a quick review, we have to remember at least what a term is and what an expression is. A term is a number or the product of a number and some variables raised to powers. And in the first table here, you see terms on the right, and then you have those terms put into expressions on the left. So you have terms that make up expressions, and expressions are nothing but a collection of terms combined by addition or subtraction or some other operation. Okay, so we have a bunch of terms together with addition or subtraction. You have what we call an expression. And the coefficient of a term is the numerical factor of each term. Okay, so when you have a term that has no numerical coefficient visible, remember that the coefficient is understood to be a 1. All right. Numbers, if a term is a number only, the term is called a constant term, or simply a constant. So you have to keep that in mind. So terms are made up of coefficients and variables raised to some powers. Expressions are made up of terms. So now we look at what a polynomial is. It's really an expression, but a polynomial is a finite sum of terms of the form ax to the n power, where a is a real number and n is a whole number. Now, what is that actually saying? So what it's saying is a polynomial is a finite sum of terms. That means finite means it has a beginning and has an end. It doesn't go on forever. Of the form ax to the n, where a is a real number and n is a whole number. Well, a in this example here is the coefficient of a term. A is the coefficient, and n is the exponent. And all it's saying here is that the n has to be a positive number or 0. N is a whole number, so it cannot be negative. So anytime you have an expression with negative exponents in it, it cannot be called a polynomial. Also, notice that the polynomial here is written in descending order of the x powers, descending. It's going from x to the 5th, to x to the 3rd, x to the 2nd, x to the 1st, and actually that 1 has an x as well. We just don't see it there, but it's really x to the 0. So any constant that you see, every time you see a constant number anywhere, you have to consider the power that is attached to an x to the 0 power. For instance, if I write down the number 5, remember x to the 0, anything to the 0 is 1. So if I write 5, can't I really say that that's 5x to the 0 power? Because x to the 0 is 1, and 5 times 1 is 5. So whenever you see a constant, you have to remember, you don't have to write it, but you have to remember that it does have a power. It has a variable with a power of 0. Look at this next expression, this one. X to the negative 5th power plus 2x minus 3 is not a polynomial because it has a negative exponent. Okay? There are 3 special names we give to certain kinds of polynomials. A one-term polynomial is called a monomial. A polynomial with exactly 2 terms is called a binomial. And a polynomial with exactly 3 terms is called a trinomial. Those are definitions. Any of them is considered to be a polynomial, but for 1-term, 2-term, and 3-term polynomials, we have these special names. Anything with more than 3 terms is just all grouped in the same description as polynomials. Okay, so now at the top of this slide, you see a table with different examples of monomials, binomials, and trinomials. And if you have more than 3 terms, like I said, we only call them polynomials. Okay, now each term in a polynomial, remember a polynomial is made up of terms. So each term of a polynomial has what we call a degree. The degree of a term is the sum of the exponents on the individual variables contained in the term. Okay, the degree of a term is the sum of the exponents on the variables contained within the term. So for instance, in this term 5y to the third, the degree of the variable is 3. So the degree of the term is 3. Okay, there's only one variable and it's raised to the third power. Look at 10x to xy. What's the degree of this term? Well, the x is to the first power and the y is to the first power. Okay, so the degree is the sum of those two. So the degree of that term is 2. Z is to the what power? To the first power. So the degree of that term is 1. The degree of negative 3a squared b to the fifth c is, now we count up all of the exponents that are on the variables. 2 and 5 is 7. 7 plus 1 is 8. So the degree is 8. For the constant number 8, what is the degree? Now remember, it's a constant, so it has an understood x to the 0. So the degree of this term is 0. So the degree of a constant is 0. That's very, very important that you understand that. If you have a number, it has a degree and it's 0. Each polynomial, though, has a degree. Now, we just finished talking about terms having a degree. So a term has a degree, but a polynomial could have several terms in it, and the polynomial then has a certain degree. The degree of a polynomial is the greatest degree of any term in the polynomial. Okay, so you have terms, and a term has degrees. Then you have those terms make up polynomials, and the polynomials have a degree. And it's the greatest degree of any term in the polynomial. So if we were to find the degree of each polynomial listed here, we can tell whether it's a monomial, binomial, or trinomial, or none of these. That should not be too difficult to do, because look at 5b squared minus 3b plus 7. Before we can find the degree of the polynomial, we must find the degree of each one of the terms in the polynomial. And then we choose the one with the greatest degree. So 5b to the second minus 3b plus 7, which one of those terms has the greatest degree? That's the one we choose to say represents the degree of the polynomial. So the polynomial degree is what? The degree of 2, because that's the biggest exponent of any of the terms. 7t plus 3, the degree of the 7t is 1, and the degree of the 3 is 0, so the degree here is 1. 5x squared plus 3x minus 6x cubed plus 4, the degree is the greatest degree of any term, which is going to be degree 3. Okay, now the first polynomial we see up here at the top is a trinomial because it has 3 terms. This second one is a binomial because it has 2 terms. And this one we call it just a polynomial, so it's none of the 3 that we have listed up there. Now we're going to simplify each polynomial by combining any like terms. Now remember, like terms are terms that have exactly the same variable raised to the exact same powers. So if we can combine them, we combine them according to like terms. Negative 4y plus 2y, are they like? Yes, they are like, so we can combine them. We get negative 2y. Z plus 5z cubed. Do they have the same variable raised to the exact same power? No, so we can't simplify this any further. So we have to indicate that by just keeping it the same. 15x cubed minus x cubed, are they like terms? Yes, because they both have x cubed, so that's going to be 15 minus 1 is 14x cubed. The next one, what can we combine? We can combine the a squared terms and then the constant terms. So we have 7a squared minus 3a squared is 4a squared. Negative 5 minus 7 is minus 12. So we've combined the like terms. Here you can use your calculator to combine terms that have fractions in them. Okay, when you combine these fractions, you end up with, my pen stopped writing, 11 over 24 x to the third, and you end up with 1/3 x to the fourth and minus x squared. Okay, check my arithmetic. I think when you add 3/8 and 1/12, you get 11 over 24. And when you add 5/6 x to the fourth minus 1/2 x to the fourth, you get 1/3 simplified if you want 1/3. And the x squared, negative x squared, can't be combined with anything. So I would rewrite it in descending order. Get into the habit of doing that. So 1/3 x to the fourth plus 11 over 24 x to the third minus x squared. If I made a mistake, let me know about it. Okay, now let's combine these like terms. So to simplify, 9xy minus 3x squared minus 4yx plus 5y squared. What can we combine? Well, 9xy minus 4yx are like terms, so we can get 5xy, but that's all that can be combined. Minus 3x squared plus 5y squared. Well, when you've got these different variables like this, you can't really go in descending order, so don't worry about it. The important thing is that you combine them. Okay, now to add polynomials is very easy. All you do is combine all the like terms. So when you're given these two polynomials here, this trinomial added to this trinomial, all you do is drop those parentheses and combine the like terms. So we have 4y squared in the first one and a y squared in the second one, which gives us 5y squared. We have a x in the first one plus an x in the second one, gives us 2x. We have minus 3y, but we don't have a y term in the second one, so we have to keep minus 3y. And we have negative 7 minus 2, which is minus 9. So we've combined all the like terms in that addition problem. The next one, we have negative 8a squared b minus ab squared plus 10 plus negative 2ab squared minus 10. All right, so let's see what we have. Negative 8a squared b doesn't have anything to combine with it. Okay, doesn't have anything to combine. But negative 8b squared can be combined. Negative 8b squared can be combined with I said 8b. Negative ab squared can be combined with negative 2ab squared. So together that's a negative 3ab squared. All right, then we have minus 10, plus 10, minus 10. Together that gives you 0. So we don't have to write that. Okay, we don't have to write plus 0. Okay, so we have combined everything that can be combined in this case. Add these two. You should be trying to work these out before I do it and then come back and check your work. So 3x squared added to a negative 3x squared, this and that, gives you a 0. So those two terms cancel each other out. They're additive inverses. Then we have 7x cubed by itself, so we can't add anything to that. But then we have a negative 9x and a positive 3x, so that's minus 6x. Then we have 11 minus 4. Okay, so it's that plus 7. Okay, have we combined everything we can combine? The 3x squareds cancel. So we have a 7x cubed minus 6x plus 7. So we've done everything we can do there. Now with subtraction, you have to be very careful if you're subtracting a polynomial from another one, because the polynomial you have to treat as a whole expression, which means when you subtract it, you have to put it inside of parentheses. And the parentheses and the negative sign in front of it means you have to change the signs of every term in the second polynomial. So I always rewrite my problem. Let's subtract 3x cubed minus 5x squared plus 4x minus now x cubed plus x squared minus 6. You have to be careful when you do this to change the sign when you're subtracting. Okay? All right, now we can just combine 3x cubed minus x cubed is 2x cubed. Minus 5x squared plus x squared is minus 4x squared. Plus 4x and minus 6. And we have it in descending order. Okay? Watch this one. It says subtract 3x plus 5 from the sum of 8x minus 11 and 2x plus 5. So first, we have to add 8x minus 11 and 2x plus 5 together. Now what I want to show you now, I'm going to show you how to do it vertically. Take 8x minus 11 and 2x plus 5 and add them together. I'm doing it vertically. Oh man, can I erase this? All right, I'm adding. Okay, so you add them, you line them up according to like terms. Just like you would line up numbers according to place value, we're lining them up according to like terms. So negative 11 added to 5 gives you a negative 6. And 8x plus 2x gives you 10x. So we added those two together. Then we can subtract the 3x plus 5. So I got now 10x minus 6 minus 3x plus 5, because it says subtract 3x plus 5 from the sum of those two. So then we change it. Change everything in the parentheses after the negative sign, minus 3x minus 5, and then we combine like terms. So we get 10x minus 3x, that's given us a 7x minus 11. All right, so that's ultimately our simplified expression. Now let's add this next one. You do it before I do it, and then come back and check your steps. So we have 3a squared. No, I'm going to go ahead on and combine them as I go. 3a squared minus 8a squared gives you negative 5a squared. Let's see, minus 4ab plus 3ab gives you minus ab. 7b squared minus b squared is plus 6b squared. Okay, and then we can't combine anything else, so there you have it. You've combined those two polynomials by addition. Now let's subtract. Remember, you want to change the sign of everything in the second polynomial. So 5x squared y squared minus 6xy minus 4xy squared minus 2x squared y squared minus 4xy plus 5 minus 6y squared. That should be the first thing you do. Change the signs, then go back and combine. So what do we have? We have a x squared y squared term here and an x squared y squared term there. Okay, so we have 5x squared y squared minus 2x squared y squared gives us 3x squared y squared. Okay, let's see if I can change color here. All right, so what about xy? We have negative 6xy, negative 4xy. Together that's a negative 10xy. Okay, and what else? We have we have a xy squared term, a 5, and a minus 6y squared. But we don't have an xy squared term to combine with the negative 4. So I believe this is all that we can combine. So we have minus 4xy squared plus 5 minus 6y squared. Am I missing something? I think that's it. We can't combine anything else. So that's it. Okay, so we've combined all those like terms, and ultimately our simplified polynomial will be 3x squared y squared. You can't really worry about putting it in descending order because these variables are all kind of jumbled up. And it is what it is. So we end up with a 5-term polynomial, and we've combined all the terms. Good luck. Watch the video again or watch Miss Elaine Martin-Gay's videos. Try these problems in the homework and bring your specific questions to me in class on Tuesday or Wednesday of next week. Have a great one.